In this video, we're going to look at approximation. So to approximate simply means to make an estimation. So now when you're making an approximation, you are bound to make errors. Yeah, no matter how accurate, at least you are going to make some reasonable error. Okay, so the way this topic is in at senior level, it just specifically look at certain things like errors, that is absolute error, relative error, percentage error, and tolerance. Okay, so those are the few things that are involved in under this topic. So I'll write them down. Yeah, so these are the types of errors that we have. We have absolute error, we have relative error, and we also have percentage error. So to find the absolute error, we use the formula recorded value minus true value. Then we also put modulus outside like this. So these bars, they simply mean whatever you find, whether it's a negative or positive answer, write it as a positive number. That's the meaning of these bars here. So that's we call them modulus. Okay, so that's how you find the absolute error. It's just recorded value minus true value. Then on 2, we have relative error. To find the relative error, we use this formula here: absolute error over true value. So this is the second formula that we use. So this one is used when finding the relative error. Then the third formula is the percentage error. Okay, so for the percentage error, this is the formula here. You can either use this one here, relative error times 100%, or you can say absolute error over true value times 100%. Remember to find the absolute error. Sorry, to find the relative error, we used this formula here. So now, if the relative error is not known, you can still use this one, whereby you put this part here representing the relative error, then you multiply it by 100%. And this is one of those topics that are very important as far as paper 1 is concerned, because they always come and they carry 4 marks. They'll ask you 2 questions, each question carrying 2 marks. If not, they'll ask you 3 questions. One question, 1 mark, the other one 1 mark, then the other one will carry 2 marks. But in total, you're going to have 4 marks that will just come in paper 1. So let's get an exam question paper here. We see how these concepts can be applied. Okay. Okay, so here's a question from the past paper, which reads: Misozi and Filamba estimated the length of a line to 9 centimeters and 10 centimeters respectively. If the true value of the line was 9.6 centimeters, find A, Misozi's absolute error, B, Filamba's percentage error. So here, the one who was making this daffoid, I think, made a mistake. This one should read if the true value, not true line. So here we should have the word value here. So here it should be value and not line. Okay, so we have 2 figures here. The first figure, which was Misozi's estimate, then the other one was Filamba's estimate. So it means the first number there, it was estimated by the person who was mentioned first there. So 9 centimeters was Misozi's estimate, and then 10 centimeters was Filamba's estimate. Okay, that's what respectively mean here. So to answer the first question here, we should know 2 things here. One, we should know Misozi's recorded value, and then the true value is given here in the question as 9.6. So let me put this question aside so that we start answering it. Okay, so let's have our solution here. So we should make we can make a data this side. We say data. So we're answering question A. So according to this data here, the recorded value, according to Misozi's estimation, what Misozi estimated, we're going to call that one as the recorded value. So according to the question, Misozi's estimate was 9 centimeters. Okay, then the true value according to the question is 9.6 centimeters. So the question is find Misozi's absolute error. So to find the absolute error, we know the formula is this one here. This is the formula for finding the absolute error. Yeah, recorded value minus true value in modulus. Okay, so we'll say absolute error is equal to, you put modulus, recorded value minus true value. Okay, so the recorded value according to our data here, we can see it's 9. So say 9 minus, then the true value it's 9.6. So we'll put 9.6 here. Okay, so recorded value is 9 minus, then true value is 9.6. We can as well put the modulus at the end here. So now, if you subtract this and this, the answer is going to give us negative 0.6. And the modulus, we said this simply means whatever you get, it must come out as a positive answer. So meaning, you can say therefore, absolute error is equal to 0.6 centimeters. Okay, so that's how we answer such questions. Okay, we move on to B. On B, the question is we find Philamber's percentage error. So in the first question, we are finding the absolute error for Misozi. So for Philamber, we just know the value which was estimated here. We don't know her absolute error. We don't know her relative error. But they want us to find the percentage error. So if we want, we can just play around with the formula. We can just come up with a very direct formula which will just go direct to finding the percentage error using the same data which is given. So we're just given Philamber's recorded value, and we also know the true value here. So we can use these very ones to find the percentage error. Okay, so let me just write the formula which we're going to apply here. Okay, so this is the formula which we're going to apply. So we don't know the absolute error. We can't use this one here because it will take time. We can't use this one here because we don't know the relative error. Again, we cannot use this one here because we don't know the absolute error. So you can just use this one if we first find the absolute error, and we can also only use this one here if we know if we first find the relative error, and that is going to waste our time because in exams we normally wrestle against time. So instead, we're going to just play around with these very formulas and come up with one here, which will just go direct. So we're going to say percentage error. This P means a percentage, E means error. So percentage error equals recorded value minus true value. So this which is on top here is giving us the absolute error. Yeah. So this which is on top here is going to give us the absolute error in the process. Yeah, which is part of, you can see, it's part of this here. So this is the same as this. According to the first formula here, recorded value minus true value is absolute error. So since we have absolute error here, we're going to put this here, recorded value minus true value. This is going to give us the absolute error in the process. Then down here I've got true value, which is already given in the question, times 100%. So the recorded value is given as 10 centimeters here in the question, and the true value, we know it's 9.6. So we're going to substitute this into our formula. So we're going to have recorded value is 10. So we put 10 here. 10 minus the true value is 9.6. So we'll put 9.6 over the true value is the same 9.6. Then we say times 100%. Okay, so now here we're going to subtract what is on top here. 10 minus 9.6. So if you subtract here, this is going to give us 0.4 over 9.6 times 100%. So now what we do here is we'll just multiply this 100 by the numerator. Multiply the 100 by this numerator here. So since this number has got zeros here and this number has got one decimal place, so we're going to remove the decimals, and then we also cancel 1 0 here. If it had two decimals, we would have cancelled all the zeros. So meaning this is going to be 4 multiplied by 10 over 9.6. So like what I said here, I said since there's 1 point here, it means this decimal number of decimal places is going to knock down 1 0 there. So it means the decimals will disappear. So we have 4 here, and you have knocked down 1 0 there. That's what happens when you multiply a decimal number and the number that has got zeros at the end. So now what will happen is if you multiply this and this is going to give us a 40 over 9.6. So we can also get rid of the decimal here on 9.6 by multiplying both numbers by 10. So you just multiply, you choose the number to multiply with depending on the number of decimals. If it has 2 decimal places, we would have multiplied by 100. But since it has 1 decimal place, we multiply by 10. Our interest is knocking down the decimals here. So if you multiply 40 times 10, we're going to get a 400 over 9.6 times 10. This will give us 96. So the 0 is going to be knocked down and the decimal will disappear. So here you check if at all there's a common factor which can go into both numbers without leaving a remainder. So we break this one by dividing by 8 both sides. So 8 into 40, it goes 5 times. So put 5 here. Here we are dividing in bits. since they are, because the numbers are too complex. So 8 into 40, it goes 5 times. Then 8 into 0, it will be 0. So meaning 8 into 400, it goes 50 times. Then we can also divide by 96 here. So 8 into 9, it goes 1 time, remainder 1. Then 8 into 16, it goes 2 times. This will give us 2. Then now you look for a number that can go into 12 and 50 without leaving a remainder. I think let's continue from here. So we have 50 over 12. So we can also use, let's use 2. No, let's use 4. So 4 into 50, 4 into 5, it goes 1 time. Remainder 1. No, it's leaving a remainder. Let's just use 2. 2 into 5, it goes 2. Yeah, 2 into 5, it goes 2. Remainder 1. Then 2 into 10, it goes 5 times. So we're going to have 25 over. Then 2 into 12. 2 into 12, it goes 6 times. So now we can divide 6 into 25. I think this is too small now. This is not complex. So 6 into 25, it goes 4 times. Remainder 1. So we put point here and add the 0 to this one here. Then we say 6 into 10, it goes 1 time. Remainder 4. So 6 into 4 into 40, it goes 6 times. Again, remainder 4. So it will be 6, 6, 6, 6, 6. And this, when you round it off, it will be 4.17%. So that's how we find the percentage error for Philamba. So if you have got any question, you can make use of the comment section. Thank you for watching.